Hello, welcome to this lecture of Biomathematics. So far we have been discussing differentiation and its application to various biological system. In this lecture, we will go to a new topic in calculus called integration. So, today we will have the first part of the integration. So, the topic is integration. Today we will have the part 1, the first part of this integration, and it will just like we had a set of lectures on differentiation, we will have a set of lectures on integration and its applications in biology. So, before starting the first lecture on integration, let us take an example and see why do we need this technique called, why do we need to learn this integration, and then we will learn what is integration and how to do it. So, first an example. So, consider the case of polymerization of actin filament. So, this is something which we have discussed before. Basically, what happens is that you have a filament as seen here, and one end of the filament is blocked and the other end is polymerizing with some rate Kp, which is the polymerization rate of polymerization. And it can depolymerize the monomers at this end, the end can depolymerize with some rate Kd. So, Kp and Kd are polymerization rate and depolymerization rate of a filament. So, what does it mean? Rate means event per second. So, rate is something 1 over time, it is like per second. So, Kp is like Kp is 10 means 10 monomers, 10 units will be added per second. So, 10 per second is Kp is equal to 10 per second means 10 monomers will be added per second, and Kd is like let us say 5 per second, that means that 5 monomers will be on an average removed in every second. So, once you know the polymerization rate and depolymerization rate, you can figure out how fast this polymer will grow or shrink. If the polymerization rate is much larger than the depolymerization rate, polymer will grow. If the depolymerization rate is larger, you can imagine that the polymer will shrink, the actin will shrink. So, this much we know. So, knowing the Kp and Kd, we can know the change in length. So, how does the length changes with time is related to Kp and Kd, and we know that it is related in the following way. Have a look at here, rate of change of length, the dl by dt, that means dl is change in length, dt is change in time. When the time changes by a small fraction dt, the length will change by a fraction dl, and this dl by dt, the change in length or the rate of change of length is nothing but Kp by Kd, Kp minus Kd, multiplied by of course the length of the monomer, which is, so basically here what L represents the number of monomers. So, the number of L is the number of monomers, in this case 1, 2, 3, 4, 5 here. So, how does this number L, which is the rate of this number depends, the length depends on this number. So, dl by dt, how does this length, which is expressed in the number of monomers. So, the length of this now is 5 monomers. So, how does this change with polymerization and depolymerization, and that is depicted by this equation, which is dl by dt is Kp minus Kd. Now, here is why we need integration. If we know this much, if we know that the rate of change of length, if the length varies with time in this particular, if we know the dl by dt, how do we get L? That is a question, and to get L from dl by dt, we need to do a set of process, we need to do some calculation, and that calculation is called integration. So, that is why we need to learn the integration. Any such equation, wherever you have a difference, so such equations are called differential equations. So, dl by dt, whenever there is a derivative at one side. So, an equation which involves a derivative is called differential equation. We will come and learn about differential equations later, but just keep in mind that when you have derivatives involved in an equation, you would typically call it a differential equation. So, when you have such an equation and you want to calculate the L from this equation, you have to do this calculation called integration. So, we would call it integration. So, once we integrate, we will get L. So, this is what is depicted in the next slide. So, how to get the length? The answer is integrate. Now, what do you mean by integrate? So, have a look at here. We know that dl by dt is Kp minus Kd. So, we can immediately write dl is equal to Kp minus Kd into dt. Now, if you want to get L, so the change in length, if you want L, you do this, you do integration and the symbol for integration. So, this calculation of integration is represented by this symbol, this particular symbol here. So, this means integration. So, if you integrate this Kp minus Kd dt, integral of Kp minus Kd dt will give you the length. So, this symbol is called integral. So, this is the basic idea. How do we do this? We will come and discuss this, but the basic idea is that if we know derivative of something, we have to do this integration to calculate the function. So, this is the basic idea. So, then that immediately leads to a question. In fact, it can be written as two different questions, but essentially, so this immediately leads to the following question. So, the question is this: if we know the derivative of a function, can we say something about the nature of the function? So, in the case we know the dl by dt, the derivative of length with time, dl by dt we knew. If we know the derivative, can we say something about L itself? So, just to get you this idea, we had here dl by dt, we had Kp minus Kd. What is L? So, this is what this is asking. If we know the derivative of a function, can we say something about the nature of the function? Or the same question we can ask in a different way. As we know, derivative is nothing but slope of a curve. So, if we know the slope of a curve, so any function can be represented by a curve, and if we know the slope of a curve, which is like slope and derivative are same. So, if we know the slope of a curve, can we say something about the nature of the curve? These are same questions. These two questions are essentially the same, written in different ways. So, the answer is yes, we can know, and we have to do this calculation called integration, and if we do this integration, we will get this answer, we will get answer to the question. So, let us look at the next slide. So, integral or integral is, so if you want to do the integral is nothing but the antiderivative, that is the opposite of derivative. So, just opposite of derivative was the act of finding slope. Previously we said if you know the curve, you can find the slope, and that technique, the way of finding the slope was called derivative. And here if we know the slope, we have to calculate the nature of the curve itself, the function itself. So, that is the opposite action, opposite process of derivative. So, one could call integral as antiderivative. So, let us say we know the slope dy by dx is m. So, m is where m is a constant. So, if we know that you have a function whose derivative is just a constant, a number, what we can integrate this equation and get y. So, we know dy by dx, and we can integrate this equation and get y, and let us see how do we do this. So, this slide shows how do we do this. So, we have dy by dx equal to m. So, let me just take you through what do you mean by dy by dx equal to m. So, what do you mean by dy by dx equal? Let us have a look at here. So, you have x and y. So, when you say dy by dx equal to m, you have a curve whose slope is a constant always. So, you have such a curve and this has a slope here. At any point if you find the slope, it has the same slope. So, this has a constant slope. So, such a curve has slope as a constant. So, dy by dx is m as a constant. From knowing this, one can write dy is equal to m dx. I can take dx this side and write dy equal to m dx, and you integrate on both sides. Integral dy is equal to integral m dx. So, basically the answer of this m dx is m is a constant, integral of dx is x itself plus an arbitrary constant. So, anytime you do an integral like this, if you have such integrals called indefinite integrals, where we will distinguish between indefinite and definite integrals soon, but if you do an integration, so the important thing to remember, the first thing to remember in integral is that integral of dx is x plus a constant. So, that is the integral of dx. So, if you from this rule, by understanding this, we can understand the integral m dx is m times x plus a constant. So, what we have is that y is equal to integral of dy is y is mx plus c. So, this is a straight line. So, you know that y equal to mx plus c is straight line, and so the one we drew here, the y equal to mx plus c line, this is a straight line and this is basically the answer. But as in the slide here, we say that c is an arbitrary constant. So, c could be anything, c could be 0, 1, 2, 3, minus 1, minus 2, minus 3, anything. So, what does this mean? This means that if you integrate this dy by dx equal to m, you can get a curve like this, or a curve like this, or a curve like this, or a curve like this, because we do not know what c is. We only know about the slope of this and slope of this, slope of this, slope of this, all of this are same slope. So, slope is equal to m. So, each of this curve will have a derivative dy by dx equal to m. Each of this curve has a derivative m. That means the integral of this, integral of m, will give you any of this curve. So, we do not know which, all these curves are answer to this, when you integrate this m, you can get any of this curve. So, we will try and understand what does this, what does this imply, what is the implication of this. But for the moment, you understand that if you know if somebody tells you that draw a curve with slope m, what would you do? You would draw any of this curve. So, if you tell you draw a curve with slope m, if you draw any of this, you do the correct answer, you are doing the right thing. So, essentially that is what is happening here. When somebody tells you to integrate dy by dx equal to m, essentially that person is asking you to draw a curve with derivative or slope equal to m, and we drew it, any of this is answer. So, in other words, the integral of this is y equal to mx plus c, where c could be anything, any constant. So, there is some freedom here to choose c, and we will come back and understand about this later, but for the moment just understand that this is the way one will do the simplest integral, and you also remember that integral dx is x plus a constant. So, now let us go to this a more general rule. So, when we learned about derivatives, we learned that derivative of x we learned as a constant, then we learned derivative of x power n as a formula, and then we could use that different places and then go ahead and do the derivative of many functions. So, we will use a similar strategy here. So, we will try and learn what is the integral of x power n. Since integral is the anti-derivative, the opposite of derivative, if somebody is asking you what is the integral of x power n, so we can ask you the opposite question. If you find the derivative of something, will you get x power n? If yes, that is the integral. So, let us have a look at the next slide. So, we have dy by dx is x power n. Sorry, this is what I wanted to write here is that the dy by dx is x power, dy by dx is x power n. That is what I wanted to write there. Basically, what, let us go back and try and do this. Dy by dx equal to x power n. This would imply that dy is equal to x power n dx. So, this is what, so you have a slope of a curve dy by dx is x power n, where n could be any number 1, 2, 3, 4, 5, 6, any number, even -1, -2. So, if you have such a thing, then integral of you can integrate both sides. So, you use this symbol integral of dy is same as integral of x power n dx, and the rule is that x power n has an integral which is x power n plus 1 by n plus 1 plus a constant. So, this is the integral of x power n, which is x power n plus 1 by n plus 1. So, where c is an arbitrary constant like we did last time. Anytime you do it's such an integral, you have to add a constant, because you are only said about the slope, you have no idea about the y intercept or anything. So, you have only idea about slopes. So, just slope alone will not give you an exact position of a curve, you need one more variable, and that variable is c. So, what you should understand from this particular slide is that integral of x power n, the rule is that integral of x power n is x power n plus 1 by n plus 1. So, now since integration is the anti operation of differentiation, let us try and check whether the derivative of this, whatever answer we got, will we get, if we find the derivative of this answer, will we get back the answer x power n. So, let us try and understand what am I trying to say. So, what we are trying to say is that dy by dx, let us have a look at here, dy by dx is x power n, dy is x power n dx. So, integral dy is integral x power n dx, and the answer we wrote that x power n plus 1 by n plus 1 plus a constant c. So, this is the answer. So, now let us find the derivative of this x power n by n plus 1. So, will we get this back to, so if we find the derivative, so basically to get the y we have to integrate dy, what you will get is y, and which is nothing but this. So, we got y. So, we found that y is equal to x power n plus 1 by n plus 1 plus a constant c. What do we get if we find dy by dx? dy by dx is a constant is 0. So, this is irrelevant, because derivative of a constant is 0. What is derivative of 1 over n plus 1 is a constant. So, let us take out this 1 over n plus 1 out, because that is a constant. Now, what you have is derivative of x power n plus 1. So, if you go back and look at the rules of the differentiation, the rule is that if you have n plus 1, that comes down. So, 1 by n plus 1 here, and the derivative of this is n plus 1 times x power n plus 1 minus 1. N plus 1 minus 1 is n. So, this and this cancels. So, the answer you finally get is x power n. So, this is the answer. So, the dy by dx, finally you get is x power n. If you have y is equal to x power n plus 1 by n plus 1 plus a constant, if you find the derivative of this, you will get x power n. In other words, if you have x power n as the derivative, the integral of that is this. So, this and this are connected, they are complementary there. So, integral of this is this and derivative of this is this. So, derivative of x power n plus 1 by n plus 1 plus a constant is x power n, and integral of x power n is x power n plus 1 plus n plus 1 plus a constant. So, this complementary operation, this is called integral or integration. Just by knowing this formula for x power n plus 1, one can learn many integral of many functions, just like we made use of the formula for x power n, derivative of x power n, to learn the derivative of e power x, sin x, cos x and so on. We can do similar things here, but just before that we have to just know one more thing, which is if we have dy by dx is k x power n. So, here also I want to write dy by dx is k x power n, sorry. So, what I want to write there is dy by dx is k x power n. Then what is y? That is a question. So, to get y, you have to integrate. Dy is k x power n. So, since k is a constant which is independent of x, in this case k is a constant which is independent of x, you can take this k out and write k integral x power n, and you have to have a dx here. So, let me write it here clearly. So, what is some of these things here are, there are some typographical errors in the slide. So, let me write this carefully here. So, the correct thing is what I am writing here, dy by dx is x power n. So, k x power n, where k is a constant. So, k is a constant, it is a number. So, dy is integral k x power n dx, sorry, there is no integral. So, you can integrate both sides. So, I can take this x dx this way. So, dy is k x power n dx, and I can integrate on both sides. So, this will give you y. So, y integral dy is y is k is a constant. So, you can take it out, x power n dx, and we know the answer of x power n dx, which is x power n plus 1 by n plus 1 plus a constant c. So, basically what does this say? This says that if you have a constant k here, you can take this out of this integration process and then do the integral of the rest of this x power n. You can do the integral of x power n alone, and the answer you get multiply with k is the answer for this. So, this is same thing as in differentiation. If you have a k times some function of x, you can take k as a constant and find the derivative of the function of x alone. So, this rule is applicable for differentiation and integration. So, once you know this, you can go to this next one, which is integration of exponential function. So, how do we find the integration of an exponential function? So, basically you have dy by dx is e power x. Now, what is e power x? As we know, e power x can be written as 1 plus x square by 2 plus x cube by 6 plus so on and so forth. So, e power x can be written as an infinite series. As we learned in earlier lectures, e power x can be written as an infinite series sum, and which is the first few terms of this infinite series is 1 plus x square by 2 plus x cube by 6 plus so on and so forth. From this, if you find the integral of this, integral of e power x, we have to integrate. So, y is basically e power x dx integral. So, as we know, just have a look at here. So, dy by dx is e power x, dy is e power x dx. I can take this aside. So, I can integrate on both sides, that is integral dy is integral e power x dx. Integral dy will give you y. So, y is equal to integral e power x dx. So, now what is integral e power x dx? So, let us have a look at this. What is integral e power x dx? So, integral, so y is integral e power x dx. So, this is integral e power x is 1 plus x square by 2 plus x cube by 6 plus dot dx. So, this is your y. Now, as we know, we did for differentiation, each of this term you can separately integrate. So, as we know, 1 into d, the first term is, so each you can find the integral of each term and sum of them. So, the integral of the first term, let us have a look at the first term 1 into dx, that is the first term. So, the first is integral of 1 into dx, which is dx, plus the second term is x into dx, the second was integral x dx, the third term is integral of x square by 2 dx, and the next term is integral of x cube by 6 dx. So, these are the terms. So, if we find integral of each of this term, you will get the final answer. So, let us have a look at what is the integral of each of this term. So, let us have a look at here. So, let us look at this. So, basically you want the integral of the, basically you want y is equal to integral of dx is basically x, integral of x dx is basically integral of x is integral x dx is basically x square by 2, integral of x square is x cube by 3, 3 into 2 will become 6. So, x cube by 6 plus 3 will have 4. So, x 4 by 4 into 6 24 plus plus constant. So, this is the answer you will get. So, you have a careful look at it. The answer you got is x plus x square by 2 plus x cube by 6 plus x power 4 by 24 plus a constant. Now, what is this constant? The constant could be any number. So, any number k could be written as 1 plus some other number k 1. So, let us write this constant as 1 plus k. It could be any constant. So, instead of writing 23, I can write it 1 plus 22. So, let me rewrite this constant as 1 plus a constant. So, let us rewrite this, y is equal to 1 plus constant k plus x I rewrite, x square by 2 I rewrite, x cube by 6 I rewrite, plus dot 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 the many terms. So, 1 plus x square by 2 plus x cube by 6 plus dot 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 plus a constant k. This is the answer y. And what is this? If you look at this, it will turn out that this is nothing but e power x plus constant k. So, the answer is integral of, so it turns out that integral of e power x dx is e power x itself plus a constant k. Some constant, it is like c, some constant, some number, it will be any number, plus 1, 23, minus 23, 100, any number depending on the k. So, it's you can put any arbitrary number and you can know the derivative of this is this. So, derivative of e power x is e power x itself, integral of e power x is e power x itself. So, once this is understood, the same way as you understand the derivative of e power x, take a paper and pen and go ahead and calculate the integral of e power x just by knowing the formula that integral of x power n is x power n plus 1 divided by n plus 1. You can basically go ahead and do this integral of e power x. Now, as we learned it in differentiation, if we know this, we can in fact go ahead and do that of pretty much any trigonometric function, because almost all trigonometric functions pretty much can be written as a power series of x power n's, x power something, right. So, let us have a look at cosine and sine, that is the next things which we should look at. So, for a moment, drink some water. So, next thing we will calculate is, we will calculate the integral of some trigonometric functions like sine and cos. So, let us take this case here, dy by dx is cos x. So, cos is a trigonometric function which we know, which is 1 minus x square by 2 factorial. So, as you know, this factorial means this exclamation mark which represents factorial. This means n factorial means 1 into 2 into 3 into up to n. So, 2 factorial means 1 into 2, 4 factorial means 1 into 2 into 3 into 4, 6 factorial means 1 into 2 into 3 into 4 into 5 into 6, 1 times 2 times 3 times 4 times 5 times 6. So, that is 6 factorial. So, dy by dx is cos x equal to 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on and so forth. Now, the way to calculate y from this is basically integrate this. So, integrate cos x dx. So, now let us carefully do this once more, just like we did e power x. So, just like we did e power x, let us go ahead and do it. So, we know that y is equal to integral cos x, which is equal to integral x minus, sorry, cos x is can be written as 1 minus x square by 2 factorial. 2 factorial is 2 itself, plus x power 4 by 4 factorial. 4 factorial is 4 into 4 times 3 times 2 times 1. So, that is 1, that is 4 factorial, minus x power 6 by 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So, this is 6 factorial. So, this is the, and you have to do this integral of this whole thing. So, you find the integral dx. So, now the integral of 1 is x, 1 dx is x. So, we can write integral of minus x square by 2 will be minus x cube by 3. So, 3 into 2 is 6. So, x power 4 will become x power 5 by 5 factorial minus x power 7 by 7 factorial, and so on and so forth, plus a constant c. So, if we do this rewrite, do this, you will end up learning that the integral of cos x is nothing but sin x. So, just like we know that if we had dy by dx is cos x, y is sin x plus constant. This much we know because we can also guess this, because if the y is sin x, the derivative of y dy by dx has to be cos x, because we know that the derivative of sin x is cos x. So, similarly, if we say that dy by dx is sin x, what will be y? So, the y will be minus cos x plus a constant c, plus a constant, because derivative of cos x is minus sin x, and with a minus sign it will be plus sin x, and derivative of constant is 0. So, this you can do like we did previously. Have a look at here. We can do derivative of sin x. So, sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial, and so on. And you can do this integral of this by knowing the formula we learned, and you will end up finding that this derivative is nothing but minus cos x plus a constant. So, basically what you learn so far is that we kind of understood why do we need to do the integration, because if we know the derivative, or if we know the slope of a function or slopes at different points, we can draw the curve itself. Now, instead of asking for the full curve, we can ask, basically, let us say we can ask the following question. Let us ask that draw a curve which has slope m, a constant, between 0 and 1. Draw a curve of slope m between 0 and 1. So, this is so previously we asked this question that draw. So, have a look at here. We asked this question, draw a curve of slope m, and then we drew many curves, because all of these curves will have slope m, which is, so you have a set of curves which are slope m. Now, we have to say a little more carefully, draw a curve of slope m between 1 and 0, which has a particular value in 1, and some other value in particular value in 0 and some other value in 1. You could ask such questions, and one could put some limits of integration. So, there are some integrals which you can integrate a function between 2 points. So, such integrals are called definite integrals, and the way we would represent this is like this. So, the definite integral is basically you can integrate this function f of x from 0 to 1. So, now here is an example of a definite integral. So, this is the function we have is f of x equal to 2, which is a line. So, this is f of x is equal to a constant 2. Now, if we want to integrate this f of x between in the limit 0 to 1, that is from here to here, we want to integral. So, if we have, so what does this mean when somebody writes integral 0 to 1 f of x dx, what does this mean? So, this means the following. So, have a look at this slide. So, integral f of x dx, you would see this at some point, some places. What does this mean is that this means that this curve between 0 and 1 can be divided into, let us divide for convenience this curve into many intervals dx1, dx2, dx3 and dx4. If we can divide like this, we can rewrite this integral as sums. So, integration is nothing but summing. Differentiation we had x plus dx minus x. So, we have found the difference. Here we are summing it up. So, since the integration is the anti differentiation, we are summing up here. So, we are summing up parts. So, f of x dx. So, if you expand this, what do we? So, what are we saying here? We are saying integral f of x dx is nothing but sum over I f of x I dxi, where dxi is intervals of dx1, dx2, dx3 here. So, let us think about this. What does this mean? So, let us draw this curve a bit. So, let us have a look at here. So, we have this curve which is y equal to 2, function f of x equal to 2. So, this is 2 and we want to find out the integral between 0 and 1. So, this is f of x equal to 2, this is this curve. Now, between 0 and 1, you can divide this curve into many small boxes. So, this is the point at 1. So, you can divide this into many boxes. So, this is one box, one box. So, dx1, dx2, dx3, dx4. dx1, dx2 are intervals. Now, what the claim which we made is that the claim we made here. So, let us have a look at this. The claim we made is the following. We said that integral f of x dx is nothing but, take the first interval dx1 and multiply the function at this particular point x1 somewhere in this interval. So, f of x1 plus dx2 into f of x2 plus dx3 into f of x3 plus dx4 into f of x4. So, this is integral f of x dx. So, we said that integral f of x dx is f at x1 dx1 plus f at x2 dx2 plus f at x3 dx3 plus f at x4 dx4. What does this f of x1 into dx1 means? So, f of x1 is somewhere in the first interval. So, let us have a look at this. Somewhere in the first interval, we want to calculate the function value. F of x1 is nothing but 2. So, the function value f at any point x1 anywhere here is 2 itself. So, this is 2 into dx1. So, basically what we calculating is height into width. So, basically what we are calculating is the area of this box. So, we calculate the area of this box, that is f of x1 into dx1. F of x2 into dx2, dx2 is this width and f of x2 is this height, which is 2. So, now we calculated the second term is nothing but the area of this box. Third term is area of the third box and fourth term is area of this fourth box. So, integral is nothing but finding the area and finding the total area under this particular curve. So, it turns out that integral is nothing but finding area under the curve. So, have a look at here. Integration is nothing but finding the area under this particular curve. So, we have this curve f of x equal to 2, and if we can find out the area under this curve between 2 points 0 1, we would say that we found the integral of this between these 2 points. So, if you want to calculate the integral of a function between 2 points, if we can find the area between that enclosed between the curve and the 0 the x axis, that is y equal to 0. The area between y equal to 0 and this curve, this particular area will give you the integral. So, let us have a look at it. So, this is this area is what we want to calculate. So, what is the area? So, area is this is 1 and this is 2. So, area has to be 1 into 2, which is 2. So, the answer has to be 2. So, now how do we find the answer? Integral 0 to 1 f of x is 2. So, 2 dx, that is what we want to find out. So, 2 into 2 is a constant, integral dx. So, we know that integral dx is x. Now, we want to evaluate this between this point 0 and 1. So, what does this such a symbol means is that this means that 2 into evaluate the x at 1, which is 1, and evaluate x at 0, which is 0. So, it's 2 into 1 minus 2 into 0, which is 2. So, this is what this means. So, let us say we want dy by dx is our derivative, and we want the integral of this between a, b, so we want to find out the integral of this. So, let us take a different example. So, let us take integral a to b dy by dx, and the answer of this is y at x equal to a. You know that integral dy by dx is y. So, you calculate the y at x equal to a and then subtract from y at x equal to b and subtract from y equal to x equal to a. So, y at x equal to a. So, this will give you, this is the answer. So, this is the rule which you want to learn now. So, the next rule of, the rule of definite integration is the technique of calculating definite integral is the following. So, if you want to calculate the definite integral of some function f prime of x, which is df by dx between 2 points a and b, first find the integral of this function df by dx, like we did before. So, integral of df by dx is integral of this df by dx is f, we know. So, the integral of df by dx is f. Then you can evaluate this f between these 2 points a and b. What does this mean is that this means that f at x equal to b minus f at x equal to a. So, this is what it. So, the answer of integral df by dx between these 2 points a and b is f at x equal to a minus f at x equal to b minus f at x equal to a. So, this is the answer. So, now let us do some examples for this. So, just like we did, so we took the first example, which is df by dx equal to 2. This is what one example we took. If df by dx is 2, we want to calculate this between. So, integration of this between these 2 points 0 and 1. So, basically let us go back to this example here. So, we had this function f of x. So, let us go back to a new example, which is f of x is equal to a function x. So, let us take this example dy by dx equal to x. Now, you want to integrate this between 2 points 0 and 2, dy is equal to integral between 0 and 2 x dx. So, I can take this dx this way and x dx. Now, the integral of x we know is x square by 2. So, the way of integral of x dx is x square by 2. So, x square by 2 at these 2 points 0 and 2. So, this represents, evaluate this x square by 2 at 0 and 2 and then subtract. So, that what it means, this vertical line and 0 and 2, this symbol means that evaluate x square by 2 at 2 first. So, if you evaluate x square by 2 at x equal to 2 square, which is this is 2 square by 2 minus 0 square by 2. So, this is basically 2 square is 4, 4 by 2 is 2, the answer is 2. So, have a look at here. Basically, what we want is area under this particular area of this shaded region. So, integral x dx between 0 and 2 means you draw this function x and mark 0 and 2, and the area of this marked region will be the integral, and the way to calculate is what we just described here. You calculate the integral and then find the limits, and you will get the answer is 2. So, this is the way of doing definite integrals, but this is just a this is a quick look into the definite integrals, but we will come back and why do we need it and all that we will discuss in the next class. So, today few things that should take back. One is integration is antiderivative, which is the complementary thing of finding derivative. So, and 2, integral of x power n is x power n plus 1 divided by n plus 1. So, if we take these two things back, we will discuss the rest, the definite integral in detail in the next class, and we will have a look at it more carefully and then try and understand where we can use this in biology. So, today's lecture we will stop here. In the next class we will discuss more about integrals. Thank you.